Okay, so today we are going to see about the analysis factor of half wave rectifier. Okay, so its input is the Vi, input voltage. So this is the sinusoidal voltage of the input. Vi is equal to Vm sin omega t. Okay, so this is the input which you are applying in the transformer. Okay, so this is the step down transformer, then this is a diode, then this is the load resistance RL. Okay, so this is the construction diagram of the half wave rectifier, right? So this is the input voltage Vi is equal to Vm sin omega t. Then this is the diode current or load current. So diode current means the current that passes through the diode ID. Okay, or the load current means IL. Okay, so in the half wave rectifier already we know that. So the half wave rectifier waveform is like this. Okay, this is the input, and in the output you will get the wave only in the positive half of the cycle. So this is the positive half, so you will get the output. During the negative half of the cycle you will not get any output, right? So here see, this is the 0, pi and 2 pi. Okay, so the one full sine wave, ஒரு full sine wave உங்களுக்கு என்ன வரும்னா 0 to 2 pi, right? So one full sine wave is nothing but 0 to 2 pi, and you will get the output only 0 to pi duration, right? During the pi to 2 pi you will not get any output. Okay, so here see, just you compare this output waveform with this equation. Your load current IL is nothing but I of t is equal to Im sin omega t. That means you will get the output Im sin omega t only between the duration 0 to pi. Okay, 0 to pi you are getting the output, and during the pi to 2 pi, that is pi to 2 pi, you will not get any output, so this value is 0. Okay, understand, right? So this is the input, and the output, this load current or diode current is during the 0 to pi duration you are getting the output, and between pi to 2 pi you are not getting any output. Okay, now let us see the peak value or maximum value of the load current. That is nothing but the Im. This is the Im. Okay, Im means what? Maximum value of this particular wave, that is called as the Im. Okay, so already you know that I is equal to V by R, nothing but the Ohm's law. Okay, so Vm divided by, you are having a two resistance, right? Ref means the resistance at across the diode during the forward bias, that is the replication of Ref, and RL means the load resistance. Okay, so now this is the first analysis factor, is also called as IDC, that means average or DC value of the current. See here, IDC is equal to 1 by 2 pi. 0 to 2 pi means 0 to 2 pi, one full sine wave. IL means input, your load current d omega t. Okay, so what is the value of IL? Is nothing but Im sin omega t. So substitute this value here. So 1 by 2 pi, instead of IL you can substitute Im sin omega t. So Im sin omega t d of omega t. Okay, now you can split up this 0 to 2 pi wave into, so 0 to 2 pi means what? Full sine wave, 0 to 2 pi. Okay, so now you can split up this 0 to 2 pi as 0 to pi and pi to 2 pi, right? So here 0 to pi, pi to 2 pi. This 0 to pi is split up into 0 to pi and pi to 2 pi. Okay, so during 0 to pi you are getting a output wave, right? So you can write like this: during 0 to pi you are getting a waveform, and from pi to 2 pi your value is 0. So from pi to 2 pi your value is 0, so you can neglect this term. So 1 by 2 pi is equal to 0 to pi Im sin omega t d omega t. So now you can take out the Im value outside, sin omega t d omega t, right? So now Im, you have take out this Im outside, Im by 2 pi 0 to pi sin omega t d omega t. Clear? Now you can integrate that. So what is the value of sin theta? Is nothing but the minus cos theta, right? So minus cos omega t 0 to pi. So you can substitute the value here, Im by 2 pi minus cos pi minus of minus cos 0. Clear? Yes. So what is the value of minus cos pi? So we have, now you need a two value. One is the cos pi value and another one is the cos 0 value, right? So you have to substitute the cos pi value and cos 0 value here, then you will get the value. So what is the value of minus, what is the value of cos pi is minus 1. Okay, then what is the value of cos 0? nothing but 1. So you can substitute this. Cos pi value is minus 1. So minus of minus 1 minus, what is the value of the cos 0? 1. So 1 minus of minus 1. So minus into minus plus 1, minus into minus plus 1 is nothing but 2. So you will get the value 2. Clear? Now 2 im by 2 pi. So I 2 it cancel, im by pi. So what is the value of IAV or IDC is equal to im by pi, or you can write, see what is the value of im? Here see I is equal to Vm by Rf plus Rr, right? So you can substitute this value here. So Vm by pi into Rf plus Rr. This is the value of IAV or IDC. Okay. So these formulas is very useful to calculate the value of the average or DC value of the current in half wave rectifier. So in many numerical problems they ask you to calculate the IDC or IAV. Okay, so if you want to derive also, you can derive it from here. Thank you.